Student, today we start exercise 2.5, question number 5. Sin x, differentiate sin x with respect to cot x. We let sin x is equal to y and cot x is equal to z. Differentiate with respect to x. Derivative of sin x is cos x and derivative of cot x is minus cosecant square x. Now by chain rule we put these values and get the answer. Now we correct question number 6. Tan y into 1 plus tan x is equal to 1 minus tan x. We move 1 plus tan x to the right hand side. Now we have this formula: tan alpha minus beta is equal to tan alpha minus tan beta over 1 plus tan alpha tan beta. If we replace alpha by 45 and beta by x, tan 45 is equal to 1. So this is equal to 1 minus tan x and 1 plus tan x. Therefore 1 minus tan x and 1 plus tan x is equal to tan 45 minus x. We remove tan from both sides. So it is y is equal to 45 plus minus x. Differentiate. 45 is equal to 0. Derivative of constant is 0 and derivative of x is 1. Here we have y square root tan x plus square root tan x plus square root tan x up to infinity. Squaring both sides. One of the square root is squared and removed, and actually total tan are infinity. If we move one of tan, the remaining value is also equal to y. Now we differentiate this value. Y square derivative is 2y dy by dx, and derivative of tan is secant square, and derivative of y is dy by dx. dy dx toward left hand side. We common this value and this is the answer. So in this question we let x is equal to a cos cube theta and y is equal to b sin cube theta. Now differentiate. Dx over d theta, we apply here power rule. 3 cos square theta and derivative of cos is minus sin theta, and sin cube 3 sin square theta and derivative of sin is cos theta. Now we apply chain rule. dy by dx, put these values and cutting, and this is your answer. We move a to the left hand side and this is your answer. Required condition to prove. Now in this question we have x is equal to a cos t plus sin t and y is equal to a sin t minus t cos t. We differentiate both these values by t. Now when we differentiate x, derivative of cos is minus sin t and derivative of sin is cos t. But when we differentiate y, in t cos t we apply product rule. Derivative of sin is cos. Here we apply product rule. Derivative of t d by dt and t and derivative of cos d by dt cos. d by dt of t is 1, and here derivative of cos is minus sin t, so it is equal to at sin t. Then we apply chain rule and put these values in the chain rule. Now from question number 10 we apply inverse trigonometric differentiation. Derivative of cos inverse is here minus 1 minus x square. Derivative of cos inverse x. But where we have cos inverse x over a, so we'll place x over a in place of x, and derivative of x over a, derivative of x over a is 1 over a. Now here we have sine inverse 1 minus x square. Derivative of sine inverse is 1 minus x square. So we put 1 minus x square in place of x, and then derivative of angle. When we square, its square root is removed, and simplify this value, and derivative of 1 minus x square, square root is 1 over 2, 1 over 2 minus 1, and then derivative of base. X square, square root is x, and 2x, so we cut these values, and this is your simplified answer. Now here we have secant inverse. Derivative of secant inverse is 1 over x, x square minus 1. We put these values in the formula, and then derivative of the angle, we apply here n over d. First we put these values in the formula, and then derivative of the angle, taking LCM, and here we apply n over d. Derivative of 2x square is 2x, and derivative of x square is 2x. Here we take LCM, and then we simplify these values. All these diameter cut by this value. Now we simplify this, and we get the answer minus 2 over x square plus 1. Now we have question y over x tan inverse x over y. We differentiate with respect to x. On left hand side we apply quotient rule n over d, and on right hand side we first apply formula of tan inverse 1 over 1 plus x square. In place of x we put x over a, and then differentiate the angle x over a, x over y. Here we have derivative of y is dy by dx, and derivative of x is 1, and denominator we place on every value, and then here we apply quotient rule n over d. First we put these value in formula of tan inverse, and then apply quotient rule on the angle. Now we multiply from right hand side the value in the bracket and move dy dx on one side and other values on the other side. From left hand side we common x dy by dx, and from right hand side we common y. So dy by dx is y over x. This is your required answer. Okay student, if you have any problem then send it to me. Jazakallah.